Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. So today's topic MOS layers and stick diagrams. So what are the major MOS layers designing of a MOS transistors? MOS layers. MOS layers. MOS layers for designing of MOS transistor. MOS layers for design of MOS transistors. MOS layers for design of MOS transistors. MOS transistors. Basic transistors are NMOS and PMOS. So basic MOS transistors are NMOS and PMOS. With this NMOS and PMOS, we can design Cmos and also we can design by Cmos. So there are four basic layers are there. First one is N plus diffusion. N plus diffusion. N plus diffusion. So N plus diffusion, it is act as a source and drain. Source and drain. Source and drain in NMOS transistor. Source and drain in NMOS transistor. In NMOS transistor. The second layer is P plus diffusion. So high impurity P type dopants diffused into the substrate area. It is a designing of PMOS transistor. So P plus diffusion act as a source and drain terminals. Source and drain terminals in PMOS transistor. PMOS transistor. PMOS transistor. The third one is polysilicon. Polysilicon is a gate terminal. It is like common to N plus NMOS transistor where N plus diffusion. PMOS transistor where source and drain P plus diffusion. So polysilicon is the same. Polysilicon as a gate terminal. Gate terminal. Gate terminal for both transistors. For both transistors, NMOS and PMOS. Both transistors. For both transistors. Now the fourth one is metal. Metal is used for conduction. Metal is used for conduction. It is used for conduction. When the signal is applied to VGS, when signal is applied to VDS, so the top layer is a metal layer which is used for conduction. Which is used for conduction. These are the major layers in MOS transistors. So let us see the NMOS and PMOS representation. So we already discussed this. Let me see the what are the basic layers. If you see this, it is a substrate area. We can diffusion here, SiO2 layer, thin oxide, and a polysilicon, and the top layer is a metal layer. Here we can take the terminals. Here we can take the terminal. Here we can take the terminal. You see this one. The layers. Let we can see. If it is an NMOS transistor, substrate area is P-type substrate area. Opposite substrate area, cap representation. And if you take this diffusion, N plus diffusion, forward lines with nearer distance, it is N plus diffusion. N plus diffusion. Now SiO2 layer, and this is SiO2 layer, and SiO2 layer is a dielectric layer in between source and drain and the polysilicon. So these metal, polysilicon, P diffusion, N diffusions, all these are isolation by using this SiO2 layer, thin oxide, separation by thin oxide, right? Let us see, this one is a metal layer for conduction, source terminal and drain terminal. Now this one polysilicon act as a gate terminal, backward lines. Metal layer is for conduction. Metal layer is for conduction. So the top layer is gate, source and drain terminal. So this is NMOS transistor. This is NMOS transistor. NMOS transistor. This is NMOS transistor. You see this one. So N plus diffusion, source and drain, N plus diffusion, and polysilicon. It is a polysilicon and metal layer. Metal layer is a top layer for conduction. Now the another MOS transistor is PMOS transistor. So for layers, what are the major layers to design a transistor? Design a transistor. Now the opposite substrate area, source and drain are P diffusions. Source and drain are P diffusions, polysilicon, and the top layer is metal layer. The top layer is a metal layer. You can see this one. So substrate area is N-type substrate area. Substrate area is N-type substrate area, backward, forward slashes. You can represent this one. And diffusion is P plus diffusion, forward lines with distance, and SiO2 layer, separation, polysilicon, diffusion, and the metal layer. Now polysilicon, metal layer, the top layer is a metal layer. So this is gate, source and drain. This is a PMOS transistor, PMOS transistor, PMOS transistor. Now you can see, so polysilicons both are same, but diffusion is different. Diffusion is different. P plus diffusion, PMOS transistor, N plus diffusion, source and drain, NMOS transistor, polysilicon same, and metal is also same. Metal is also same for conduction in this NMOS and in this PMOS. Now let us see the stick diagrams. Let us see the stick diagrams. Stick diagram. What is stick diagram? It is representation of a transistor with color stick. So stick diagram means it is a representation of a transistor, representation of a transistor, representation of a transistor with color sticks, with color sticks. Color sticks is called, color sticks is called stick diagram. It is called stick diagram. Stick diagram. So representation of a transistor with a color sticks. Now use some use the basic transistors and what is the stick diagram. Let us see this one. This is a NMOS transistor. NMOS transistor. NMOS transistor. So gate, drain and source terminal. Gate, drain and source terminal. It is NMOS enhancement mode transistor. Now what is the stick diagram of this one? The stick diagram of this one representation, you can say, so red over green, red over green. So this is a drain terminal, source terminal. The color is green. The color is green, and this one is a gate terminal is a red color. Gate terminal is a red color. So instead of a transistor symbol, if we represent this gate, drain and source with a color stick is called as a stick diagram. So it is a stick diagram of NMOS. It is a color stick diagram of stick diagram of stick diagram of NMOS. Stick diagram of NMOS. Stick diagram of NMOS. So let us see another NMOS transistor. If it is a depletion, NMOS depletion mode transistor one. So how can we represent this NMOS depletion mode transistor? This is a transistor symbol. What is the stick representation? NMOS depletion. This is NMOS depletion. This is NMOS depletion. So gate, drain and source terminal. So what is the stick representation? It is again red over green. Red over green. This is a red over green, red over green with yellow implantation, with yellow dotted line. You see, this is a yellow dotted line. Representation of this transistor, instead of transistor symbol, we can represent with the color stick. Color representation is called as a stick diagram. Now, so the gate is a red color. The gate is here red color. So gate terminal. Now, this is drain and source terminal representation with the green color. This is a green color, red over green and yellow implantation. This is yellow dotted line, yellow dotted line, yellow dotted line. So it is a representation of red over green with yellow dotted line. So we can write here, red over green. Here red over green, yellow dotted line. So this is red over green, yellow dotted line, yellow dotted line, yellow dotted line. Right. Let us see the PMOS transistor. PMOS transistor. PMOS enhancement. PMOS enhancement. PMOS enhancement. Now in PMOS enhancement, then what is a stick diagram representation? PMOS is a bubble representation. So gate, drain and source. So what is the stick diagram of this one? So polysilicon is same. Polysilicon is same. Red over yellow. This is red over yellow. Red over yellow. So drain, this one is source and a gate terminal. So what is the color? It is red color. Red over, this color is yellow. Red over yellow is PMOS enhancement mode transistor. We can write this red over yellow. Red over yellow. PMOS enhancement mode transistor. Now PMOS depletion mode transistor. PMOS depletion. PMOS depletion mode. Let us see this one, PMOS depletion mode. Let us see the transistor here, PMOS transistor. If you take the depletion, there is a thick line between drain and source. Then it is a depletion, channel establishment between drain and source. In NMOS also we are seeing channel establishment between drain and source. It is a depletion mode transistor. So depletion mode transistor, what is as like NMOS transistor? So yellow dotted line is there, and red over yellow with yellow dotted line. Red over yellow. This is a red over yellow, red over yellow, and yellow dotted line, yellow dotted line. So it is a representation of a transistor, representation of a stick representation instead of a transistor symbol. It is a transistor representation in color stick. Now let me write the, so it is a gate terminal, gate deposited on, you see, gate deposited on drain and source, gate deposited on drain and source. So deposition on drain and source, separation of drain and source and gate with a thin oxide, with a thin oxide. So it is drain, source. So here the color is red color gate, red color gate, dotted line is yellow dotted line, yellow color dotted line, and this one is yellow color, yellow, drain and source yellow representation and yellow dotted line. So mostly use enhancement mode transistor, so less in depletion mode transistor. So let us draw NMOS inverter stick diagram. Now let us draw NMOS inverter, NMOS inverter stick diagram. Let us draw NMOS inverter stick diagram. Stick diagram. Let us draw this NMOS inverter stick diagram. So we have an inverter. We have inverter. How can you draw this in stick diagram? So NMOS inverter, pull up transistor, pull down transistor. So the pull up transistor is depletion mode transistor. Pull up transistor is depletion mode transistor, and pull down transistor is enhancement mode transistor. This is a depletion mode transistor where you can see the channel establishment between drain and source, and the enhancement mode transistor, no channel existed, no channel existed between drain and source. So by applying external gate voltage, there is a channel establishment. So this is a NMOS inverter. Then then it is the supply voltage VDD, ground voltage VSS, output voltage is a depletion mode transistor. So depletion transistor, depletion mode. This is a depletion mode. Channel already establishment, depletion mode. So it is also called a pull up transistor. Pull up transistor. Pull up transistor. This is pull down transistor. Pull down transistor and enhancement mode transistor. Enhancement mode transistor. Enhancement, no channel existed. By applying external gate voltage, there is a channel establishment between drain and source. Now, here input we are applying to the enhancement. Output is with respect to this enhancement. So depletion is always on transistor where VGS is equal to 0. Where VGS is equal to 0. We are not applying any gate to source voltage. Already channel established, path established, there is a current flow from drain to source. Now what is the stick diagram of this one? So first we can take the, here I want to tell you this VDD VSS are blue, supply voltage, supply VDD, supply VDD, metal is a metal, The color is blue. Ground also, supply and ground potential VSS used in metal, and the color code is blue. The color code is blue. So let us, instead of this circuit representation, transistor representation, we can represent with the color sticker. First we take the VDD VSS. First we take this VDD VSS, and drain source. These two transistors are connected in series. Then I can take completely a green, because seriously connected. Drain source, drain source, drain source, drain source. So two transistors are connected in series. I can take directly a green color. How many polysilicons are there? There are two polysilicons are there. One is from above this one and below is this one. So two gates are here. Here this gate is a short circuited gate, and here we are applying input voltage. So now we can take gate terminal here. So red is the gate terminal, polysilicon, and you see. So this gate is a enhancement, and this one is a depletion polysilicon gate. Now depletion means yellow dotted line. So another one is, we can represent this in yellow dotted line. Yellow dotted line. So stick diagrams are very important in the examination. Maybe ask you design NMOS inverter or any other logic is given, you can draw the stick diagram. So let see this one. Supply voltage is VDD. It is a metal representation. We can say it is a blue. You can say this is a blue color. Blue. Here also blue. So VDD and VSS. So here also we can take output. Output terminal is also metal. Output is taken here a metal. So output is metal. So this is a metal means a blue. Blue color is a metal is blue color. Blue. Now the name of this terminal is output terminal. Now let us see the polysilicon. Polysilicon is a gate. So the name is input. Here we are applying input here. The color is red color. The color is red color. The color is red color. And we have interconnection part. So this is the interconnection part. A square box, black color representation, joining of diffusion and this metal. Here also interconnection part, joining of this metal and this diffusion. Metal and this N plus diffusion. And here also we can say this one is a metal and this polysilicon. Okay. Now, so what is the color of this one? This is a black contact cut or contact area. Contact area means contact of two layers, metal and this diffusion. Polysilicon and this metal. Polysilicon and this metal. Here, metal and this diffusion. So this is a representation of a NMOS inverter stick diagram with this circuit. Now let us see NMOS inverter. By using NMOS inverter, by using the NMOS inverter, by using NMOS inverter design logics, inverter design logics, design logics, design logic stick diagrams. So by using NMOS inverter, logic design logics are here. Some logics are here. So with that logic, we can design NMOS inverter. So first, for example, Y is equal to A plus B into C complement. It is a logic. we need to design by using NMOS inverter. So design this logic. Design this logic. Design this logic using NMOS inverter. NMOS inverter. And draw stick diagram. And draw stick diagram. And draw stick diagram. So let us see this one. First we can draw the design with this logic by using NMOS inverter. You see this one. You see this one. So VDD VSS is there. Above one in NMOS inverter, depletion is constant, which will not change. Depletion is constant, which will not change. Okay, which will not change. So it is always constant, which will not change. So the logic in NMOS enhancement will be changed. The logic in enhancement will be changed. What is the logic here? A plus BC. A, yesterday we are seeing NMOS. A plus means parallel and B into C and logic means series. And logic means series. A is plus. You see, A is plus. Okay. A is plus means parallel. So before that, let me draw here. Take some space. So A is parallel and B and C are series and logic. B and C are and logic. You see this one. So both are in parallel. Both are in parallel. So A is parallel with the B and C. B and C are series. Series means an NMOS and logic. Series means and logic. And last B into C. B into C series. A plus. Plus means parallel. So A is in parallel with the B into C. So then it is a VDD, VSS, and output from here. We can take output from here. Output from here. We can write this output. What is the output? A plus it is parallel. A plus B and C are series. We can write it as B into C, and pull up transistor and pull down transistor is there. It is pull up is a depletion mode transistor. So pull up, pull down, it acts as an inverter. This is an inverter complement. Because of this pull up transistor, the load resistance depletion mode transistor act as an inverter. It is act as an inverter, the complement. Now let us draw the stick diagram for this logic where NMOS transistor design. It is by using NMOS inverter. NMOS inverter means depletion mode transistor and enhancement mode transistor. You can see this one. Pull up, pull down transistors. Pull up, pull down transistors. And let us take this green color over here. You can take green over here and one green over here, another green over here. We can interconnect. Both terminals are same. Then we can take same color. You can interconnect from here to here. Okay. And polysilicons. How many polysilicons are there? One polysilicon is a gate term short circuit polysilicon depletion mode transistor. So this polysilicon is a depletion mode transistor. One polysilicon is A. Another two polysilicons are, these two are series and A is parallel with this B into C. Now you got this one. So depletion mode transistor. Depletion mode transistor means yellow color representation. This is a yellow color representation. This is yellow color representation. Now we can take output. We can take output is a metal. metal over here. Now we can take a contact area, interconnecting of joining of layers. Here we can get the interconnection point over here, interconnection point over here. Here also we can take interconnection point over here, output terminal, and interconnection point over here. So diffusion and the metal. This is also interconnection point is here. Now we can take the terminals A, B, and C, and input output. So this is VDD, VSS, and Vout. So this is a strict representation of a NMOS inverter design using the logic, circuit diagram, and with respect to stick diagram. Let we see the second one. Y is equal to A into B plus C. A into B plus C. B plus C complement. So it is A plus B into C. A into B plus C. So design this NMOS design style. Using NMOS design style. NMOS design style. Let us see this in NMOS design style. The circuit diagram is VDD, VSS. So pull-up transistor is a depletion mode transistor. Depletion is constant and it will be same. And A is in series with the B plus C. In series with the B plus C. So how B plus C are parallel? So B plus C are parallel. You see this one. B plus C are parallel. So these are parallel. B plus C are parallel. A is in series. And the output terminal over here. Here we can take the output terminal. Now we can represent this. A inputs are A input B plus C are parallel. B plus C are parallel. These two are parallel. A is in series in and logic. So A is in series with the B plus C and depletion mode transistor and VDD. This one is VSS and Vout. VSS and Vout. Let us see the stick diagram. So blue color. VDD, VSS are blue color. You can practice this. You can practice this. Here only any Boolean expression. We have AND gate and OR gate. AND gate, AND logic and OR logics are there. So AND means series. Plus symbol means parallel logic. Now VDD, VSS are there. Now let us take the diffusion over here. Diffusion over here. You can take diffusion and green terminals are here. So we can connect this drain terminal same green. That's why I'm connected over there. Now let us take the polysilicon. One polysilicon is a short circuited polysilicon, and another polysilicon is for A terminal. This is a B polysilicon gate and C polysilicon gate. Then afterwards depletion, representation of a depletion. Depletion is a dotted line. Depletion is a dotted line. Depletion is a dotted line. Now let's represent this blue color representation. Blue is a VDD. So this is VDD. So blue color VSS. Okay. And red color A, terminal B and terminal C. The color is, this one is red color. Red color and green is a diffusion. Green is a diffusion. N plus diffusion. Now the interconnecting point. So we can take here is a metal as a output. Then the interconnecting point is a black contact. Interconnecting means two layers are here, metal and the diffusion. Metal and the diffusion. Here also metal and the diffusion. Here also diffusion and this metal. So output. This is a Vout. Vout. Vout is the color representation is blue color. This is a blue representation. Blue representation. So VSS are blue color. So diffusion green, diffusion green, diffusion green, diffusion green. Polysilicon is red. Red over green, red over green, red over green. Where interconnection point is there you can represent the black color. Now one more two example. You can see Y is equal to AB plus CD complement. Let us see this one in NMOS design. NMOS design. NMOS design. So how can you represent NMOS design and stick diagram? Let us see the circuit diagram. So VDD, VSS are here. First we can draw the depletion mode transistor. Let's take some space. So depletion mode transistor here. Depletion mode transistor is constant, which will not change, and changes the logic in enhancement. ABR series. You can see this one. ABR series. ABR series. AB. This is A. This is B. ABR series and CDR series, and both are in parallel. You can see this is AB, okay, and CD R series, CDR series, C into D means series. So ABR series, CDR series, both are in parallel. Both are in parallel. This is a logic, and according to the logic, we have drawn the circuit, right? So let us representation of this terminals. So what is VDD and VSS? So output is terminal is output terminal, okay, and A, B, C, and D. Now see the stick diagram. See the stick diagram. So VDD, VSSR, VDD, VSSR, blue color, and let us take the drain terminal, drain and source, green representation, okay, and we can take this one is for two transistors, this one is for two transistors. Diffusions. So how many polysilicons here? Two polysilicons are here, AB, two polysilicons are here, both are series, and these two are parallel. And here this polysilicon is a short circuited polysilicon, right? Short circuited polysilicon. Now you can see the terminals we can write here, blue color, blue VDD, here also blue VDD, VSS. Now we can take the output terminal here. From here to here we can take output. So it is V out. V out is blue color. Okay. Let us see, and this one terminal A, terminal B, terminal C, and terminal D. The red color. It is a red color representation. So 1, 2, 3, 4, 5. Okay, and yellow implantation is also there. Yellow implantation, depletion mode transistor, yellow dotted line we can represent one. Yellow dotted line we can represent. And where the contact area, contact contact area means two layers are joining. Metal and diffusion, metal and diffusion, metal and diffusion here. And polysilicon and this output metal. And this one is diffusion and this metal. This is a representation of a stick diagram according to this logic. The last one we can see, the fourth one, y is equal to previous AB plus CD. Now A plus B into C plus D complement. So you got idea. Now you can draw easily with your own. So what is the circuit diagram? Tell me, ma. Yeah, okay. So first we can draw the VDD VSS. Depletion is common. Depletion is common, which will not change. The logic is changed in the enhancement. So A plus B. So A plus B. A, this is A and this is B, parallel. A plus B means parallel. Parallel circuit. Parallel circuit. Okay. Now C plus D are parallel. C plus D are parallel. Both are in series. A plus B and C plus D are series. So you see, this is a C plus D parallel, and both are in series. You see, this is a series. Now we can take this inputs and outputs supply VDD. This is VSS. You see, depletion mode transistor A plus B, A, B, C, and D. And here is the output terminal. So how can you draw this stick diagram? Instead of the circuit designed with the logic, we can take a color representation. VDD, VSS are blue. VDD, VSS are blue. Now take the diffusion over here. So we can take one diffusion over here, and we can take one diffusion over here, and here two parallel diffusions are here, A and B, and here also two parallel diffusions are here. Okay, let me take the polysilicon. This polysilicon is a short circuited polysilicon, and this is a, and this is B, and this is C, and this is D, and joining of between the two transistors by using a metal. This is a metal layer, metal layer. Here also we can take output metal layer. So let me represent this. Represent this in inputs and outputs color representation. Blue color for VDD. Okay, and VSS. This color is blue, and here also Vout. Vout is blue representation. Blue representation. Now polysilicon terminals are A, B are parallel, C, D are parallel, and A plus B and C plus D are series. Now yellow dotted line is there. This is yellow dotted line. Depletion mode transistor. Depletion mode transistor. Now let us take the contact area. So interconnection of here. This is the interconnection point. Here also polysilicon and metal is interconnection point. Diffusion. Both diffusions are interconnection. Metal and diffusion here. Metal and diffusion over here. Series connection. Here also metal and diffusion. The ground metal and diffusion is here. Okay. So these are the logic. As per the logic, you can draw the circuit diagram in NMOS inverter, and you can draw in the stick diagram. Okay, then tomorrow we'll see the CMOS logic inverter and stick diagram. Okay, please subscribe the channel, like and share with your friends. Thank you.